Is your character a girl?
No. Is your person Max? No, but this is the board game Guess Who.
You win. Let's play a game. Can you guess who?
Guess who? Game cards do not actually talk.
It was created in the early 80s, and it was probably my favorite game to play as a kid just because the rules were so simple. Now, we each had different guessing strategies as kids, but now that I've taken a bunch of math classes dealing with probabilities, I wondered if there was a way to just totally dominate every game. So I thought about it a bunch. Probably more than I should have, but it turns out there is a super simple guessing strategy that is perfectly legal that theoretically will win you more than 96% of your competitive Guess Who games. I tried it out on a bunch of people and it absolutely works. So I've been documenting the past 2 weeks of my life, and instead of just giving you guys the answer, I want to share in the process of discovery, because I feel like most of the times that's the coolest part. So I'm running about 20 minutes late, but I am packing right now to take an airplane ride to visit someone I haven't seen in 18 years. His name is Mr. Malloy, and he was my high school statistics teacher. Basically, I think I figured out a killer Guess Who strategy, but I want to pick his brain about it. So as a quick reminder, in Guess Who, you each draw a card, and that's your character. Then, for example, you could start by asking, does your person wear glasses? And if they say no, then you would flip down all the people wearing glasses. Then you take turns asking yes or no questions, and the first person to narrow it down to 1 wins. I think the biggest strategic question is whether it's better to ask broad or narrow questions. For example, there's 5 people with hats. So a narrow question would be, does your person have a hat? Now there's about a 20% chance they do, and if you're right, you've narrowed it down to 5 and practically won. On the other hand, if you ask a more broad question that applies to say 10 people, there's a greater chance the answer will be yes, about 40%. But because it was more broad, you're still left with 10 people to guess from as opposed to only 5. So my ride is here. But while I'm traveling, try and think of which of the 2 strategies is better. I'll give you a hint. One is definitely way better than the other, and the difference is the key to sort of unlocking the super killer strategy. And I'll just say, I've had literally hundreds of teachers over the past 30 years, and teachers don't make a difference. Awesome teachers make a difference. The guy we're about to meet is one of 4 or 5 teachers that have had more of an effect on shaping me into the person I am today than all of the rest of them combined. Each of those awesome teachers had their own teaching style, but I think the common thread was I could just tell that they cared about me as a person, and their passion about the subject they were teaching was contagious. You'll see that in a minute with Mr. Malloy. That's why whenever a teacher asks me to Skype with their classroom, I always try to find time to make it happen. Mainly as a fist bump to that teacher for caring enough to do something more than just reading from a textbook. Cool, man, thanks. I have not seen Mr. Malloy in 18 years, and he is in this classroom. I'm scared. Here we go. What's up? Brothers don't shake hands. How are you? The years have been kind to you, old friend. So there's 24 characters. Yes. Okay, so here it is. I mentioned 2 strategies earlier. One was a more narrow guessing, and one was more broad. I always find it useful in cases like this where the answer isn't totally clear to sort of look at the extremes.
Does your person's name rhyme with Alfred?
No. So Sarah's question is so narrow it only applies to one person. Is your person African American?
Yes.
And thankfully we've evolved, but in Milton Bradley's defense, it was the early 80s and casual racism was still acceptable. You see, with a super narrow guessing strategy, 1 out of 24 times, you'd actually get it right on the first guess. But equally likely is that you don't get it right until your final and 24th guess. And since it really has an equal chance of being any one of those numbers, on average it will take 12 guesses to win. Now let's look at the other extreme with the really broad question. So the broadest question would apply to exactly half of the characters. So no matter if the answer is yes or no, you knock down half. So starting with 24, then it goes to 12, then to 6, and then to 3, and then to either 2 or 1. And then your final guess. So in this case, you would always win in 5 or 6 moves. So any other combination of narrow versus broad questions, including the 10 and 5-person questions I mentioned before, would just fall somewhere in between. And this gives you a huge advantage because the game is intentionally designed to ask narrow questions. So prepare to have your mind blown. But every single attribute in Guess Who applies to exactly 5 people. So 5 people have glasses, 5 have mustaches, 5 people have red hair, 5 have hats, blue eyes, 5 are women, 5 are bald, blonde hair, black hair, white hair. Exactly 5 people even have big noses and rosy cheeks. So given that every attribute applies to only 5 people, how can you possibly ask a question that applies to exactly half of them? Well, there's several different ways to do it, but one idea is to ask a question like, does your person have white hair, or red hair, or glasses? Now this is perfectly legal since the rules state you just have to ask a yes or no question. Then on your next turn, you just pick some combination of attributes that applies to half the remaining people. Another idea would be, does your person's name start with the letters A through L?
No, that sounds right.
Okay, good. I have his approval. Okay, and now for the hard part. I want to know what is the true probability of me winning with this strategy, right? I want to know when I go into battle against my 6-year-old nephew,
right,
how confident can I be that I'm going to win?
Right.
Can you do that?
Yeah.
Okay.
Yeah.
Statistics! Let's talk about it.
Well, here's an example of a random event happening. There's 256 little BBs in here.
Okay.
And when they drop through the hopper, they always make this normal curve. It's a random process. But you do know that the group will always look like that. It's fascinating.
And what's also fascinating is that anytime you have a bell curve like this in real life, it always breaks down to the percentages you see here for each standard deviation away from the average in the middle. So for example, every time you flip that card over, about 38% of the BBs will always fall into the chute in the middle.
So even though your strategy is better than your opponent's, sometimes you'll win. So knowing from the mean and the standard deviation and the normal curve calculations, we can calculate how often you'll win in 3 moves. Okay. And how often you'll win in 7 moves, say. Okay. And then if you multiply those probabilities together using the multiplication rule, you'll actually get a little square here, and that says what's the probability of that game happening. And you can fill in this whole grid and know all the probabilities of certain game occurring. And if you add these up, we have 99% of all the outcomes of the games. You lose 14% of the time.
And you got that by just saying 2 plus 2 plus 2 plus 2 plus 6.
That easy, yep. You win 63% of the time.
This is super cool because these percentages for a bell curve match up with exactly what our BB showed us earlier in real life.
Right.
So just to make sure I got this, for our hypothetical situation here, there is a 38% chance my opponent will guess their person in 6 moves.
Yep.
Now, I'm a little better, so there's a 38% chance that I will guess my person in 5 moves.
Yeah.
So the chance of having that game happen, where I win in 5 guesses versus his 6 guesses, is 15%. And
Right.
that's because 38% times 38% equals 50.
Yep. You just multiply. It's just like a rectangular area.
Just like old times.
It's
we
like-
multiplied all the time
Yeah.
in your class.
Just like back in the day. All that multiply.
Now, one of the things I remember from your class is that I can't just like play 3 games and assume that that's going to be statistically valid, right?
Yes.
How many games of Guess Who do I need to play to be confident that I have the right distribution?
You would have to play 625 games.
That's a big number.
That's a lot of Guess Who.
That is a lot of Guess Who. So I have 625 games to go, but at the end of that, my goal is to find the true bell curve for the standard strategy and the true bell curve for my tricky strategy.
Right.
And then at that point, I can populate this chart and then I can add up the pink numbers.
Right.
So that means if I sit down and play my 5-year-old nephew, and guess who? I'll be like, there's a 90% chance I'll win. I'm gonna destroy the underground Guess Who gambling market in Vegas with one YouTube video. So it was gonna take a while to finish 625 games. So I called up my super smart buddy Chad, who you might recognize from when we built the annoying coworker countdown NES hack.
Oh gosh.
And with Chad's big brain and a computer program he wrote emulating the standard guessing strategy, after 1,000 games we discovered the typical Guess Who player will take about 7 guesses with the standard deviation of about 2. So when you plug that into Mr. Malloy's chart, we find that the improved guessing strategy will win 80% of the time. Now at the beginning of this video, I promised you would win 96% of your Guess Who games, and the key to get there is just to play first 1 to 5 wins. Guess Who actually calls this championship mode, and they even provide pegs for you to keep track of the first 1 to 5. The reason this increases your chances so much is because of what's called the law of large numbers. Basically, the more games you play, there's a regression to the mean, or a convergence to the predicted probability. So this dashed line is your predicted winning percentage, but to win overall, you just need to win more games than you lose. So you want to be above the dried spaghetti line at 50%. Now this spot here is just pizza grease and has no meaning. So you might get unlucky and lose the first game, but then you win the second game. Now this frozen chicken nugget will represent the running average, and right now it's right in the middle. But let's say you get unlucky and lose the third game. If the match was over now, you would lose since the nugget is below the spaghetti. But the law of large numbers states that over time, the chicken nugget will migrate towards the dashed line and then just stay there. So after a while, you can see that even if your opponent goes on a hot streak, the nugget doesn't move much, and you can pretty much guarantee victory since there's no way it will dip back down below the spaghetti. This is exactly why Vegas casinos have no windows or clocks. They have a small statistical advantage, so the longer you stay there, the more they are guaranteed to come out ahead. And it's also why if LeBron James ever challenges you to a game of one-on-one, do not play best 2 out of 3. Play 1 game. First point wins if possible. But you know what I like a lot more than children's board games? Knowledge.